Thank you, Sam. And the best thing to do for me is to welcome you because I've checked where people are from. I should say good morning, good afternoon, good evening, and good night. And thank you for taking the time. I know how these webinar things work, and not everyone watches it live. So to the majority of you, I should say, hello, dear audience member from the future. And to some brave souls, I should say, thank you for being here today. This is not my first webinar, nor is it my first webinar for platform engineering. It's part of a series. This is part 2 of 2. And for me to be able to explain everything you see here on this slide on how virtual registries secure, control, and strengthen CI/CD artifacts, we need to look back at the previous webinar I delivered. You can watch it on YouTube if you want to, but here are the Cliffs Notes. So previously, not on 24, maybe you've seen the series back in the day, but previously on platform engineering, I talked about artifacts. Now, the term artifact is a very abstract word, but in the context of software development, a lot of you probably will know what it is, yet I will still provide a definition. So an artifact is either a dependency or a product of the software development process. It helps define, design, build, test, or maintain a system. So it's just dependencies in the software development process, or you building a dependency. Because I need to remind you, or maybe not, maybe you're aware of this, that software, at least modern software, is assembled. It's not just written from scratch. Regardless of the language you use, the environment you use, the orchestration tools you use, you probably have some sort of dependency. We use terms like modules, packages, libraries, and so on and so forth. You'll probably know some of these logos. So we categorize them in 3 specific categories. Typically, there might be more. So it's language dependency. So whether you're writing your code in JavaScript or PHP or .NET or Python or whatever it is, Go, Rust, you name it, it has a package manager. It has a way of pulling in modules. A second category are the runtime components that are typically hosted as packages on an operating system. The Linux packages, the Alpine packages, the RPM packages, the Debian packages. Those are there to install dependencies that your runtime will need. And the third category is probably the most modern one. It's the Docker images, the Helm charts, and all the other infrastructure as code and orchestration material that is out there. So I talked about that, and I talked about how these things are stored in repositories and registries. And might I remind you, using this diagram, that a repository and a registry is not exactly the same. An artifact or multiple artifacts can be contained in a repository. So a repository contains them. The transport happens by a registry. So that means multiple repositories can be hosted in a registry. Now, of course, no need to tell you, but I'm still going to. It's all part of the CI/CD context. And another thing I mentioned in the previous webinar, here's a quote, is that between 20 and 40% of the total CI/CD pipeline time is consumed by dependency downloads. And that's a huge challenge. It's a problem. And people need to fix that. They're looking for ways out. And I talked about caching as a solution to that, to make it faster. A lot of you know what caching is, but still, a definition is in order. Caching is storing a pre-computed result for later usage aimed at reducing the computational and network pressure while improving performance. So it's storing something pre-computed so you don't have to recompute it again, and that makes it faster. And I positioned that, and maybe you should check out that webinar at some point. It's on YouTube, on Platform Engineering account. I talked about the power of caching in a hyper-localization context. It means putting the caches as close as possible to where you need them to reduce network latency, improve performance, and why cache artifacts? For that faster delivery, for a better scalability of your environment, not scaling the repos, not scaling the infrastructure, but the performance, to lower egress costs for cloud-based artifact registries, and also resilience. I don't need to remind you of that because it happened last year and probably this year as well. Cloud platforms can go offline. So you need some sort of resilience mechanism, offline mode, if you will, to protect your systems. Because if that cloud, that big hyperscaler has an outage, your registry is probably going to be hosted on that. And that means you can't pull in those dependencies. And that ultimately means your CI/CD pipeline is blocked. You can't go live. It's not just that. The resilience aspect also deals with the rate limits that are very prevalent on these public registries. Who here in the audience has already experienced that, doing a bunch of Docker pulls from the Docker hub and ending up with rate limits? It tends to happen. I talked about virtual registries, and here's where we get on brand, right? There's a little bit of intro I need to do. I talked about virtual registries. And a virtual registry is that virtual layer that you use to abstract direct access to artifact registries. And it kind of looks a little bit like this. So you have the different registries, you attach a virtual registry layer to it, and that ensures that access is consistent, that caching can happen, and a bunch of other things. Now, this is what it would look like with logos on top of it and better structured. So on the right-hand side, you see the clients. Those are the CI workers, those are the CD workers, or it could be individual developers. From a developer's perspective, you could do an npm install or a Docker pull on your computer. The CI workers are typically your GitHub actions, your GitLab actions, Circle CI, and a bunch of others that are quite popular. Those are your clients. The virtual registry sits in the middle and protects you from the impact of having to access these registries at scale. As you can see, there are public and private registries. The public ones, you know them. Those are the public PyPy, Rust Cargo, NuGet, npm Maven, you name it, all those public registries. It applies to Docker and Debian as well, or just your source code. Source code could be an artifact as well. Your GitHubs, your GitLabs, that can be accelerated too. Now, a lot of organizations, and I'm curious, and I'm going to keep an eye on the Q&A here, who here uses these universal repository managers like a JFrog Artifactory or a Cloudsmith, Sonatype, Nexus, Harbor? Those are more at the private spectrum. Those might be self-hosted or in a SaaS model on the cloud that host private applications, private artifacts, and those need to be authenticated. Now, in that registry, virtual registry webinar that I delivered, I think it was November last year, I talked about the capabilities, but I focused specifically on caching. But today, ladies and gentlemen, I'll focus on the other capabilities, on routing, security, observability, and more. Talk about a long intro. Hi, everyone. Thanks for joining me again. My name is Thijs. Yes, that's how you pronounce it, Thijs. I'm a Dutch-speaking Belgian. I'm the technical evangelist at Varnish Software. And I know, folks, I know the title's quite a lot and the picture certainly doesn't help. But Varnish Software, for which I am the tech evangelist, is, you might have heard from us, you might not, is a company that builds software-defined web acceleration and content delivery solutions. Somewhat of a strong emphasis on software-defined, which means if you buy the software in its purest form, you can run and install it, deploy it wherever you want. That could be with a hosting company on a VM or on your own bare metal hardware, could be in the cloud, could be in containers, could be in Kubernetes or any other orchestration mechanism. We accelerate everything that speaks HTTP. Historically, we were known for websites and APIs. In a second phase, which started around 2018, we saw an uptick in popularity of video streaming platforms, which also required acceleration. And nowadays, I think the starting point of that was 2024. We saw a big need for acceleration at the object side, at the artifact side. And the message I have for you is we accelerate all the things. Yes, you might recognize that meme. Now, things have evolved slightly. We're not purely a software company anymore. We also have a CDN offering. And we've launched that CDN, well, it's a coincidence, right? Today we launched Varnish CDN, so you could go to varnishcdn.com. And as we are a European company, we offer like sovereign digital services under the form of a CDN for Europe. So that means all that power that Varnish offers, you can now have that in a SaaS model under the form of a CDN. Now, if we visualize Varnish as these three dots, it acts as a reverse caching proxy. And the user could be a browser, could be a mobile app, could be whatever, and the server is a server. However, in this context, the context of today, the server will be a registry. Your client will be part of the CI/CD process. And we're not going to talk about pure Varnish anymore. Varnish is the toolkit, the technology toolkit underneath. We need to go a level higher and talk about virtual registries. These virtual registries are deployed in front of your actual registry, as I've explained, but they could be distributed. I mentioned hyperlocalization. You need to position them exactly where you need. So you might have a developer hub somewhere. Well, you'll position it close, maybe even in that office. You might have a Kubernetes cluster. Maybe you'll install a virtual registry inside the Kubernetes cluster. Just wanted to point that out, that while this is a uniformous layer of abstraction, it can be physically distributed while being presented as a single layer logically. But And I've mentioned this, I hinted towards this, but here's how we're really going to shift gears. It's not just about the performance. The performance is nice, but as we position this, because we build virtual registries, other companies do that as well, we noticed that a specific clientele said, great, we see the value in it, and we'll take the caching and the performance as a given, but we want this universal control layer. It's actually about control. And that's a big concern for a lot of enterprises, a lot of organizations. They want a better handle on security. They want to use that sort of universal layer in front of their registries for routing. They want to choose, maybe my NPM packages go to npm.js. Maybe my PyPy packages will go to Sonatype. Maybe something else goes elsewhere. So having that control over the routing without having to reprogram all the systems, without having the developers to switch it up, it's a consistent point of entry. I mentioned resilience already, offline mode, dealing with rate limits, and observability. Let's focus on security for a bit, because security is important. And if you look at companies who started out in the acceleration space, I mean, you can look at any CDN out there. They're slowly evolving into security companies. We haven't done that fully, but we're on a path. There's no denying it, and there's no escaping it. Security is important, and there's tons of security risks out there on the internet. I mean, as seasoned professionals that we have here, like we have a nice crowd here, you've probably been through it, have some horror stories from the trenches. From a CI/CD perspective, from an artifact perspective, it's a different kind. You have the typical ones. You can still have a DDoS attack, but we now see supply chain attacks. Now, let me go into supply chain attacks and the definition of it. What is the digital supply chain? Well, it's all the dependencies that you need. So if you can infect one package, it might travel around the world and be installed on a ton of systems if that package is popular. Now, of course, we're not here to claim that we reinvented the wheel or found this magical solution. We do know we're part of an ecosystem. And that ecosystem has the repositories and the registries who already are doing a lot in terms of security. They have the vulnerability scanning in place. And what they tend to do is they tend to focus on understanding where the risk is at rest. Where are the things happening that need to happen and how they can deal with it. And from a repo security perspective, they just identify known vulnerabilities. And when they spot something, they'll enrich the artifacts and add some metadata. And as you can see, risk context, they prioritize issues based on the exploitability or just the business impact, and they help you towards remediation. However, all of that happens at rest. A lot of it could be filtered out, but in a lot of cases, it's either not dangerous at rest, only at execution, and there's different kinds of registries and repositories, each with their own capabilities. So what they typically don't do is control the moment of execution. And that's where a virtual registry, like the one we develop or like the one other companies develop, I mean, this is not a product pitch, right? This is me just positioning the concept of a virtual registry. And you have many incarnations of it. I'll just do it from my perspective. And our perspective is that the moment of execution is where the risk really takes a hit. Like, you should be very wary of code being pulled in. If it's on a disk, it's not really dangerous. And I'll give you one example, a relatively recent one that made some waves. Apparently, maybe you've heard of it, maybe not. Let me know if you have, is the Shai-Hulud worm. It's a widespread supply chain compromise, specifically targeted at NPM. And I'll explain what it is. You can find it on the CISA.gov website. You'll find an in-depth description, but let me break it down for you so you understand what the typical risk is here. And don't get me wrong, a lot of packages were infected. So what it typically does, this type of worm, just like all the other worms, is it tries to infect a user's system. That's step one, of course. And it does what it needs to do, but among the things it does credentials harvesting. So on your system, if the worm infected you, it's going to look for GitHub authentication credentials, NPM access, or the big hyperscalers like AWS, GCP, Azure, and it will harvest those credentials. Not only will it exfiltrate that stolen data and send it to a remote location, it will also infect the packages that it finds on that system to propagate it even further. So it will infect the packages. Maybe you are the author of an NPM package. It finds it, it puts the JavaScript code in it. The folks at GitLab written a pretty good blog post on it and showed some actual code that found its way into that supply chain attack. And here's the kicker. What it does, if it has those credentials and it infected the packages that you're the author of, it will propagate that and push it with a new version. So all of a sudden, these really popular NPM packages have a new version, a minor version that is bumped, but it's the one that is infected. And thousands, maybe even millions of other systems just pull that in. And the chain goes on and on and on. And apparently it even has a dead man switch that destroys evidence when it notices specific infrastructure is being taken down as in part of the process. So this comes from GitLab, and you see the link here to the GitLab blog. They show a nice little diagram of what happened here. So all of these or this Shai Hulud worm isn't that dangerous when it's on your system. It really gets dangerous when someone pulls it in. And that's the question we need to answer. So I hope this example was a good one and shows you what the risks are and what a supply chain attack is. The question isn't really, is the artifact risky? Is this version of this package risky? The real question is it okay to pull it in right now at this moment in time? It's not, is it on the disk? It probably is somewhere on the disk, but is it dangerous when I pull it in now? And that's the role of the virtual registry. But make no mistake, virtual registries aren't there to replace artifact repository security. We're not trying to be a competitor of these companies, not at all. We collaborate. We sit in front of them. We don't take away their capabilities. We just offload pressure and add capabilities. Capabilities such as augmenting the security measures they have in place by offering a consistent control plane at the point of access, not at the point of ingestion or storage. So looking at it from this perspective, again, you have our nice little diagram again with the virtual registry covering for the private and public registries. It's a single endpoint, sort of a logical one size fits all, come in and fetch the registry kind of deal. And we provide the security and the caching and the routing and the observability there to protect you. However, at the backend side of things, I mean, it's not like JFrog or the Docker Hub aren't doing anything. They do their deep analysis and their scanning and their governors and probably have rules for DevSecOps people. We just do the inline enforcement the moment it gets called. And we have those consistent policies. You can define security policies on the edge, if you will, in the virtual registry. But the power is that it goes across the registries, across clouds, across tool chains, across implementations. And that means you have this consistent streamlined behavior that doesn't depend on capabilities of the individual registries behind the scene. And it's not like we, again, reinvented the wheel. These are things that have been out there in the traditional web style security and resilience. If we take it back to the regular web, where the user could be a browser and the server could be an Nginx or an Apache server serving static websites, those things have been there for years, maybe even decades. I mean, again, if I refer back to the CDN market, they have rate limiting in place and bot detection and DDoS protection and have application firewall rules. Like, it's all there. Like, from a security perspective, you can easily enforce that for websites. Resilience goes even further. I mean, HTTP has resilience baked into the protocol with the caching headers. Offline mode, if you will. And that's where like basic caching comes into play. If something is cached, you can keep serving it even though the infrastructure behind the scenes is down. So that means your CI/CD build could still run pull-in dependencies, even though maybe AWS has an outage which affects your registries. And I talked about the protocol itself having it. I mean, we talk about the web context and I'm talking about artifacts and registries, but deep down underneath, we're talking HTTP here, folks. And HTTP has built-in caching mechanisms and has a stale if error directive in the cache control header to say, like, look, this can be cached for 3,600 seconds, which is an hour. When it expires, you need to revalidate. However, if whatever you're fetching from is down, keep serving it for another day, which is 86,400 seconds, or until it comes up again. So plenty of capabilities, plenty of opportunities there. But again, we're talking about virtual registries. So we need to elevate the conversation again and not talk in strict HTTP terms or web terms. We need to talk in artifact terms. So what is needed to make this happen is an artifact firewall, a firewall that has artifact-specific knowledge, protocol-specific knowledge. And for that, I'd like to introduce you to Orca. Orca is a product that we developed, has a free tier, or it's in fact it's actually the opposite way. It's a free product that has paid tiers. And it is that actual virtual registry. It is readily available and is built on top of Varnish with all the underlying capabilities, but with that intelligence. So you can just go to varnishsoftware.com/orca and just you see the Docker pull command there on the screen. You can run it and get started. It supports many different kinds of implementations. And a little side note I'd like to make is that it supports private packages as well. It piggybacks on the authentication mechanisms and caches it in a really efficient way without creating content duplicates while still enforcing access control, which is important for private packages. So if you want to deploy that and start taking advantage of that virtual registry, like you can literally run this command on your computer right here, right now, or copy paste it from varnishsoftware.com/orca, and it'll be up and running. It requires zero extra configuration out of the box. Of course, you have the ability to configure, because underneath there is a config file that abstracts all the rules that we write in our own programming language, which is called VCL. We just elevate it to more of an artifact level. So you can deploy it on port 80. You can mention the remotes that you want to connect to. So Docker Hub primarily lives on docker.io, but you can use the GCR mirror as a backup. There's npm.js, there's Go, there's GitHub Container Registry, and more and more and more. This is just an abbreviated version. You can throw Let's Encrypt into the mix because you'll probably need TLS for that. And you can inject all of that custom config, your own registries, just mount it into container and get started. And if you're a Kubernetes person, we even have a Helm chart to do that and a values.yaml file that you can inject to it to tune it to your needs. If you want to up the pressure and do it at real big scale on bare metal, don't worry, we've got you covered. We have Debian packages and we have RPM packages. And once you've deployed that, once you have that virtual registry in place, it's really a pull-through cache. So when you test this, and I invite you, ladies and gentlemen, to test it on your local computer. On my system, everything with the .localhost prefix is an alias to my localhost IP 127.0.0.1. So instead of doing a Docker pull from the Docker Hub, I do a Docker pull from docker.localhost, and I attach the suffix library Ubuntu. And this will pull the Ubuntu image from the cloud, from the Docker Hub, into Orca, and we'll have it there. And then you remove it again with Docker image remove, then it's and you're doing it again, you'll see a massive speed increase. And you can do it for NPM, and you can do it for Go, and you can do it for Helm, and so on and so forth. But that's just the plain virtual registry side of things, primarily focused on resilience, performance, and observability. But there is a artifact firewall component to it. And I'm happy to mention that we are not just in the process of developing it, we are in the process of finishing it. We've developed it and made a very specific implementation that we'll present soon. So the way this artifact firewall works is that it has intelligence on the artifacts that it tries to deliver. So what it does is, as you pull in all sorts of artifacts, it inspects the manifests, because every type of artifact has a manifest that provides metadata that gives you the available versions. And what we do is we inspect those versions and we inspect those artifacts, and we look at policies that you can define as part of a rule set. And those rule sets could be hosted on a repo, could be a Git repo, and we'll pull it in and actively modify the manifests to deny access or hide unapproved versions based on those policies. So you as a user are none the wiser. You do your Helm install or your Docker pull or your npm install, and we'll make sure that if there's a version that is not allowed through the rule sets, to either deny access or just to hide it. And hiding means just turning the latest version of that artifact into the latest approved version. We typically position it behind the virtual registry. I mean, the virtual registry is there for performance, your single layer into it, your routing, your observability. And then before you head to the registry, we go to the firewall. And then the enforcement, as I previously explained, that enforcement happens at request time. So let me give you a little bit more on those rule sets. They're kind of interesting. So you can actually match package URLs using a specific syntax, or version matches, allowing you to specify rules on a per package basis, or even with glob patterns, regex matches, semver, so semantic versioning comparisons. And here's what you can do. That's the second bullet point. You can whitelist things. You could say it's allowed. You can outright deny access to certain criteria, maybe a version or a version range. You can allow it, but still log that someone pulled it in. And then your DevSecOps people can look into it. Or as I explained, hence the asterisk, you can hide it, meaning you can make sure that the latest tag of that package points to the previous one that was approved, not the one that was matched in the rule set, which is pretty interesting. Now, of course, we don't remove that version. We only remove the tag. If you do version pinning on a specific version, we won't stop you with hide. We'll stop you with deny, but not with hide. And we allow all those rules to live in YAML files that you can host on a centralized repository, maybe even a GitHub repository. And we provide a doorbell API. Every time you post new rules to it, the firewall will be notified, will pull in the new rules and will enforce them. And in the future, we'll even do integrations with CVE services, OWASP or OSV.dev to dynamically create those policies based on like new exploitations, new CVEs that come in. And we'll also build an API so that DevSecOps people can pull in either logs from things that were pulled in that they weren't supposed to pull in, or enforcement notifications, or even an API to allow, disallow, hide, or enable logging for certain criteria. And I've been talking about these rule sets for a minute or 5 now. So here's an example of what that could look like. So the first one we allow. So apparently the PURL, the package URL, is an NPM package of a package called Lodash. And the specific version is 4.17.15. And in the reason, we gave it even a support ticket number that explicitly allows this package. It's been scanned, it's safe. Someone in the security team approved it. Great. But on the other hand, there is a whole range of packages that we don't allow. Something fishy went on and we created a rule for it. So the PURL could either be UA parser, or it could be RC or COA. And for COA, it's not a single version. It's everything greater than 2 or equal to 203 and smaller or equal than 204. So you have the flexibility, and we deny. And the final example is a hiding example. We suspect something is going on with colors, but we don't want to block everything. We just want to hide it. If you're doing version pinning, you can use it. If not, you will never even see it. That's how these rule sets work. Now, I told you that we're in the process of building this. We will present it. We will be going to KubeCon, and I hope some of you, I'm not sure about people outside of Europe, if you'll go or not, but I hope to meet some of you there. We have a booth at KubeCon, and we will showcase that artifact firewall. It's happening March 23rd to 26th in Amsterdam. So I hope anyone in there who comes up, come say hi, I'll buy you a drink. So that's the security aspect of it. Let's quickly, because I won't keep you here for too long, talk about observability, because that's also part of the influence that an organization wants to have and the control they want to have. They want to see things. Now, observability is the ability to understand a system's internal state by analyzing telemetry data. Observability and telemetry, those terms are often interchanged, but the telemetry is actually the collected machine-generated set of signals. So you have a signal, a collection of signals is telemetry, and what you do with that telemetry can give you observability. Typically, you can have logs, metrics, and traces. And like 15 minutes or 20 minutes before this webinar started, I ran a couple of those things, and I took some screenshots and screen grabs. Here's the logs that Varnish generates. It's a subset even of logs for a single transaction. So as you can see, with the rec URL tag, I did a Docker pull of the Ubuntu latest Docker image, and that generates a whole lot of log transactions. Like the level of in-depth information is astounding. Now, mind you, this is all part of a free product, right? You can actually test this tonight if you want. You see all type of information, some analysis we're doing. We inspect OCI registries. We set the repository, manifest all that information. We provide metadata. We look things up in the cache. This happened to be a miss, and we respond, and there's a lot more response headers. Everything is in there. That is just the client-side transaction. Fetching, the actual fetching from the registry is a separate transaction. So you have a ton of data out there. You can filter, you can use a command like varnish log. There's other commands you can use to explicitly get the information about requests, responses, caching, duration, byte sizes, you name it. That's the zooming in part. That's up close. When you zoom out, You can get statistics as well. So if you run Varnish stat on the system, you can see how many requests we sent, hits, misses. This is just a subset of all the metrics. It's a continuously updated list. But when you would run Varnish stat -1, it would dump everything. And when we do a word count, on this basic setup, we already have 2,811 metrics. Now, this is not a brag because that many metrics could be confusing, but there's just a lot in it and you can filter accordingly. And then the question is where I'm going to see all this information. Yes, we support the standard stuff, right? Yes, we support Prometheus and Grafana Loki. Loki is the logging centralization bit. Grafana is the dashboard, and Prometheus stores the metrics. Now, be careful with storing everything in Loki. It gets kind of verbose, but we tend to create JSON exports. There are commands you can use to create JSON exports with exactly the data you need. But of course, this is all very implementation specific. I would also like to say that we have an open telemetry suite that you can connect to it. We will further develop it, of course, to have those nice distributed traces with registry and artifact related metadata under the form of attributes, all of that. We have that for Varnish as our technology toolbox. We're building that for the firewall and for Orca. And ladies and gentlemen, this is just the tip of the iceberg. I just wanted to show you some capabilities. I wanted to introduce you to the concept of registries, of virtual registries, the problems that arise, the performance issues, the cost, but also the opportunity that a lot of organizations see after deploying it to use it for security and for resilience and observability. This is a product that is in constant development. We have dedicated colleagues building this out. I think when we look into maybe the second half of the year, we probably have tons of extra capabilities. One little capability that is in development that I like to quickly reference, not really talk about because it's not the purpose of this presentation, is S3 optimization. We talk about registry-specific and repository-specific logic. You've seen plenty of it throughout this webinar, but sometimes things are just hosted on S3 natively. I mean, some of these registries use S3 as an underlying storage, but some blobs, some files are just stored on S3. And Orca also has the capabilities or will have the capabilities of interacting with that. That means we support AWS's signature protocol. We can validate signatures, we can re-sign, we can connect to the native S3 or S3 compatible competitive alternatives. So S3 optimization is not something we've forgotten, and it will be part of Orca as well, together with the firewall. I think that's very much a Q1, Q2 kind of thing. So let's land the plane, the proverbial plane, and give you the call to action again. If you want to play with Orca, go to varnish-software.com/Orca. We have a Docker image, we have Helm charts, we have Debian and RPM packages. Go give it a try. It's not like you need to sign up or get a credit card. It's free. Just pull it in and play around with it. And remember, this is just one of the things we do. We accelerate all the things. Right, that's all I had, folks. Let's start looking at the Q&A and at the chat. So let me stop sharing my screen.
That was awesome.
And see what the situation is. What is the situation?
Well, let's dive into the very first question.
Yeah, let's go questions first and chat box later.
Yes, yeah. Well, people need a little bit of a
breather,
little bit of breather, time to absorb. That was a lot of awesome info. So, but let's dive right into Santeri's question to start.
Yes. So I'll read the question verbatim so everyone else also knows what's going on. What is your take on products like Google Assured, open source, and other hardened images dependencies? Well, one of the things, I've done a lot of presentations, a lot of webinars, and the key thing to do is to admit when you don't know. I'm not going to spin a story around this, Santeri. I have no idea. But that's not the end of it. It's not because I don't have an idea now that I won't have an idea in the very near future. So what we'll do here is I'll look up what these products are. And if you want, you can reach out to me. You can connect with me on LinkedIn and we'll figure it out there. And I assure you by the next time we have a conversation, I'll probably have a decent answer for you. Sorry to give you that disappointing kind of answer. So
Well,
the next question, a
can't know
very, very
everything.
relevant question. What will happen if the virtual registry is down? What happened? What will happen to our CI/CD? Well, yeah, when it's down, it will be down. Of course, your CI/CD won't be able to pull it in because if your point of entry is down, then you're pretty much screwed. But here's the deal: because this could be distributed, you have failover mechanisms. We are also in the process of taking our Varnish clustering and optimizing it for artifacts. So that means you can have multiple nodes distributed either within the same data center or in different data centers, different regions, and have a level of synchronization that is not pure replication, but that is sort of a clustering with a primary and secondaries. So the solution is just like the solution that all the big cloud players tell you to do. Don't put your eggs in one basket because eventually we will go down. We've seen it with Amazon and with Google and with Azure. They all go down every now and then. But if you architect that into your setup, then you'll be safe. So that means you'll probably have a secondary option somewhere else. Long story short, you can distribute your virtual registry in different physical locations. When you have an outage, that either you have a failover under the form of clustering, if you will, or if there's an actual physical downtime of hardware that only one region is affected, your blast radius is reduced. I hope that is a sufficient answer. Oh, another one from Jaap Brasser. What signals tell you that it's time to introduce a virtual registry? That is a really good one. I'll tell us a short story, but I'll promise I'll keep it short. So what happened is that we weren't even aware of that need initially. We've built artifact solutions for clients, and all of a sudden, clients started asking us questions. Apparently, if you're running things at a certain scale, you'll feel the pain. So the short answer to your question, Jaap, is you'll feel the pain when it's there. So the typical signals are, it could be complaints about performance. Like if we take my previous webinar and this one, we smash it together, it could be, it just takes too long for the CI/CD pipeline to run stuff. And if you look at your CI/CD pipeline and you see that artifact, pulling in artifacts, it takes in the majority of the time, that is a decent answer. But it should be actual pain, of course. Another one is if you're worried about security or you have sprawl, developer sprawl. That's a typical one in certain organizations. Each developer introduces its own tool chain. Someone develops something in Rust, another one in Node.js, and all these things start spreading across the organization, and you're struggling to keep track of it. If that is an organizational risk and you get the mandate from management to get a handle on it, then a virtual registry might control all your points of entry and exit. It also gives you the observability to know who's doing what. So in summary, it could be a performance issue. It could be risk of not covering all of your security stuff. It could be the developer sprawl, but it could also be cost. That's a big one as well. Because you cache locally, you don't always have to pull stuff from the internet. And certain platforms, I know JFrog Artifactory has a model there, is based on bandwidth. So the more you pull in, the more costly it gets, and these things compound at scale. So let's say you have a lot of build pipelines, a lot of developers working on things, well, that cost will compound. So I hope that gives you a pretty clear picture of certain signals you need to keep in mind for you to make that decision. Another one from Prince Kumar, can we customize the virtual registry to run our own type of compliance or security test? For now, I would say no, but it's not a real no. I mean, what we've done is we've productized one typical implementation of a reverse caching proxy like Varnish. We've built tooling around it and found some sort of common ground where everyone could get some value out of it. If you really want to customize it to your exact needs, I think if you buy the commercial version of this or an enterprise version of it, you'll get access to the actual source code, and this is not C code, this is our own rules and policy language called VCL, and you can start implementing it yourself. So while from a product perspective, the answer would be probably not, from a technology perspective, definitely. You get access to the underlying system and you start tuning things yourself. Okay, if there Are there any more questions? Well, one of the questions was like, will there be a replay? Yes, it's on YouTube, and Sam already shared the link here. And will the slides come online? Yes, I'll create a PDF export. I'll send it to the lovely people at Platform Engineering, and it will probably find its way to you. And with that, I think we're almost at our allocated time. It's where I'm at. It's 7:42 p.m. And thank you for sticking around. Like we had a good audience. I appreciate. Prince Kumar said, "Waiting for the next session. When is it?" Well, there's probably more. Why don't you come to KubeCon, Prince, and we'll meet each other there. So thank you, everyone. Even though I didn't see you in real life, it felt good hanging out virtually with you. So I hope to see you again. And thanks to you, Sam.
Amazing. Thanks, everybody. This was awesome, and see you in the next one. Bye.